Well, in this section, we're going to look at properties of logarithms. And these properties are basically rules of arithmetic of logarithms, and they'll eventually help us to be able to solve equations that have multiple logarithms in them. Let's look first at the product rule. As usual, b is going to be a real number, and m and n, they're going to be all positive real numbers, and b is not equal to 1. So m and n are both positive, so m times n is going to be a positive number, so we're allowed to take the log of it. And the log base b of m times n, these two numbers multiplied together, you can break this up into log base b of m plus log base b of n. It works every time, and this is called expanding the log expression. Notice we started with one log, and then we've expanded it into two slightly more simple logs. We don't have to do the multiplication of m times n anymore. So product rule, you need to memorize that. Let's just do a couple simple examples to show how it works. Well, this is obviously log base 6 of 77. 7 times 11 is 77, but it's broken up. You could break it up yourself, or I chose to write it like 7 times 11. So all that means is that's equal to log base 6 of 7 plus log base 6 of 11. All right, so those two are equal. And this one, it's the log of 100 times x, which means log of 100, log of 100 plus log of x. So the base always stays the same. What's the base of this one? 10. So notice that in breaking it up like this, we actually know what this value is. Log base 10 of 100 is 2, because 100 squared gives you 100. 10 squared gives you 100. So I would prefer that anytime you write something like this where you know the actual value of it, actually write that number. So this would be 2 plus log x. Log of 100x is equal to 2 plus log of x. All right, now let's look at this. Well, this would be natural log of 3 times e is the natural log of 3 plus the natural log of e. E. So one of these we know. This is equal to 1. Natural log of e is what exponent do you raise e to get e? It's a 1. So we could write this like 1 plus ln of 3. Okay, that's expanding the log expression. And it is my preference, I want you to, when you know the actual value of one of the parts of the expression, simplify it. We got a 2 there. Here we got a 1. All right, now you can probably figure out what the quotient rule is going to be. Maybe. Here is the product rule. The quotient rule is when we take log base b of a fraction, a number over a number. Well, that says it's going to be like this, only we use subtraction. Log base b of m minus log base b of n. That's also expanding the log expression. We're taking one log of a fraction, we're expanding it into 2 logs, and notice that when you're multiplying, it turns into an addition problem. When you're dividing here, m divided by n, it turns into a subtraction problem. And we just expanded that log. Okay. A couple examples. This is very simply log base b of 23 minus log base b of x. Log of the top minus log of the bottom. This one gives us log of 1,000 minus log of w. But we know that portion. What is the log of 1,000? It's base 10, so what exponent do we raise 10 to get this number, 1,000? 3. 10 squared is 100, 10 cubed is 1,000. So 3 minus log of w. Then we get this. The natural log, which is log base e, of the fraction e over 11, will be ln of e minus ln of 11. But we know one of those values. Natural log means log base e. So the log base e of e is just the number 1. 1 minus ln 11. And that's expanding the log expression. Okay, we have one more rule that is considered expanding a log expression, although it won't expand it very much. That's called the power rule. So, b, m, and n as usual, positive real numbers, and b is not equal to 1. Let p be absolutely any real number you want it to be. Notice p is the exponent here. So we're taking log base b of m to the p power. Basically, all that means is you can take the exponent p and move it down to the base level and multiply it in front. P times log base b of m. Okay, so if you're multiplying a log by something, you can either just put the p out in front, or you could make it an exponent of what you're taking the log of, like right here. All right, so let's do a couple of examples. Okay, so we have log base 5 of 7 to the 4th power. All that means is you can take the 4 and make it a multiplication down here. It's really desirable in many cases to do this because you don't want the exponent. Sometimes you don't want the exponent, and it allows you to bring it down to this kind of base level. So that's equal to 4 log base 5 of the number 7. Let's do this one last. Let's jump over to this. Here we have the log of 4x to the 5th power. So we're going to bring that 5 down to there. So that's equal to 5 log 4x. Okay, and the parentheses are optional. It does make it more clear. But if you take the log and then there's something multiplied together, you multiply before you take the log. Well, what do we do in this case? There's no exponent. But we can rewrite that as ln x to the 1/2. Remember, radical x means x to the 1/2 power. So now I can move the 1/2 down, and I get 1/2 ln x.